substation automation started with the ABB, and there are, I mean to say, initially it's basically your I was mainly in the commissioning and testing of which helped me to go deep dive into the technologies which is used in the substation automation. And one of the technology which is really prevailing in every utility is substation automation using IEC 61850 standard. This standard is now widely popular all over the world. It was introduced in early 2000, and now almost all the countries started following the standard for this implementation of substation automation. So I won't directly jump into the standard, but I will just introduce you what is the basic substation automation all about. Maybe there may be some very basic terms I'll be explaining to you. Apologies for that, because I just wanted to bring the context before I go into the standard and how we use the standard for this implementation of substation automation. So you are free to ask questions. Amrit, I think you will be taking questions through the chats, right? If I'm not wrong.
We'll give some instructions to participants.
Yeah. You want to give an instruction now?
It's already posted.
Yeah, it's already posted.
Okay.
We'll just repeat.
Okay. Let me just. Okay. So let me start then, because we have only 1.5 hours and we have around some next.
All questionnaire and all they will post in chat. At the end of session, we'll go through, sir.
Okay. And if someone is drawing pictures on the slide, I think I see some lines here. So I think I don't know why it's happening, but I think it's clear now. So these are the topics which I'm planning to cover. This first part is the basics of substation automation. That is, I'll be explaining what is an utility, what is a substation, and what are the basic functions in substation automation. Then I will give an introduction of this specific standard, and then why this standard came into picture. Then I will a little bit deep dive into the topic of the specific standard and how the standard will be used to achieve this basic substation automation function, which I explained before in the first topic. Then finally, I'll give an idea of what is the performance requirement as per the standard. And I have a part 2, but part 2 I will not be covering today because it's another 1.5 hour session. If people are interested, I can take it in another session. So let's go to part 1. It is a animation which you can see it. I will not explain. You can just have a look at that, what's happening on the screen. Once it is done, I will explain what it's all about. But it's very well understood. So if you look at the top left corner, you have a power generation, and it goes through, you step up the voltage and send your power through a high voltage line, transmission line, and you bring to a transmission substation, and further you will step down and will come to some main substations. You'll further step down, and finally it comes to the consumer. Why I mentioned here, so when you're transmitting a power from a power generating station to the final consumer, it is going through the different substations. So you can see this, there are substations just after the utility generation side, then you have the transmission side, then the consumer side. So this topic is specifically on the substation automation. What is the functionality which is happening in the substations? So that's why I put a context here. So on a definition point of view, if you read out the substation here, electrical substation is a subsidiary station in a complete utility where the voltage is transformed from high to low or the reverse using the transformer. So electric power flows through many substations before it reaches to the final consumer. So it goes multiple voltage changes before it reaching to the final consumer. Let's go to, so this is something just to give an idea of visual representation of the substation. So you might have seen most of them, you might have seen it, but still I just thought that I can just give you an idea of how it looks like. So this is an air insulated station where you can see these pipes. What you see, these are the current carrying conductor, and they are on a high voltage, and between these conductor the insulation medium is air. That's why we say air insulated substation. But you can see that this will be a very big station. I mean, if you have 400 kV station, it will take lots of land. But there is other substation which is called gas insulated substation, where you don't see a conductor exposed. They all are in the pipes, what you see it here. Why? Because now instead of air, the insulation medium is SF6, that is sulfur hexafluoride. So you don't need much distance between two conductors. So you can keep it in a very context setting. Then I am coming to the basic functions in the substation automation. So there are mainly three functions in the substation automation. One is protection. Then you have control functions and monitoring function. I'll just touch upon each and everything, but this is going to be in detail. I am explaining in the coming slides. Protection means you're dealing with a high voltage current and some insulation failure. It can happen. Insulation failure can result into some kind of a fault where instead of the normal current, very high current will flow. So that is kind of overcurrent or earth fault protection. Then, because in this condition, what you are supposed to do is that is what substation automation function all about. Whenever there's an earth fault happens or overcurrent happens, what sort of function should activate in the substation automation? That I will explain in the next slides. Then control. So, for example, in a substation, if you have to send a power from one to another location, it's like in your house you have switches, right? I mean, say if you have to switch on a light, you have to press your switches. Same like you have switches in the substation, but they are not the switches what you see at home. That's called circuit breaker. They are very big equipments, so they are automatically operated, I mean to say. So you have to close the switch to transmit the power, open the switch to isolate it. So stop the power from flowing to a specific area or specific location. And third is the monitoring. So it's also important when you have a big substation, we should also get an idea of what is the current is flowing in each and every line, what is the voltage there, and what is the position of these switches which I mentioned about, whether it's a closed or open. Or also I'm interested, there are many transformers in the substation, whether there is a temperature issue in the transformer. So these things I would like to monitor, because if you allow it to cross some limits or not on a desired operating condition, then you are supposed to take some action. So these are the main three functions which we have it in substation automation function. But you also have many other, but this is sufficient to at least understand the basics of substation automation. If there are any question in between, maybe Amrita, you can stop and just let me know the question.
Okay.
Great. One important thing you should know as a substation engineer is that when you're designing a substation engineer, we use one term called single line diagram. Single line diagram is basically you have, for example, I just explain you here, then you will understand. So there is a power coming from a transformer and is coming from this side as well. Then you have a current carrying conductor bus, a copper bus. Then you have you are evacuating the power into different locations. It will be to one look towards feeder one. You are sending the power to one location, and you have another one here. So you are bringing the power into the substation and you're evacuating the power from here. So for design and to easy understanding point of view, I will not write all the three phase here. It's sufficient I show only one line. Instead of RYB, I will say only R. So it's almost R, Y, and B will be replica of R. So we need to only, for a design point of view, I need to only show the R phase here, or L1 or A phase. How do you do that? So you can see you have for example, there's a next term is important term which I'll be using repeatedly in the coming slides is bay. So main reason for me to introduce single line diagram is to explain the bay. So in a substation, a collection of equipments which is used for bringing the power into substation or evacuating the power from the substation is called bay. So if you see this here, I will just explain here. This is a current carrying or conductor. It's a bus, we will say. From the bus, we have some switch. It's called isolator. I'm just representing as a line, isolator. And you have the main switch, which I say circuit breaker, which is circuit breaker, which you need to close and open for, sending the power and or disconnecting the power to a specific location. And you have some equipments. This I will explain you in the coming slide. So please try to remember there is a term called bay, which I will be, because I'll be taking the base in the next slides to explain the different functionality. So what I have done, I'm going to explain you the first function, which is called protection. I took only 2 bay from the previous picture. That is sufficient for me to explain. There's a transformer. So there's a power flowing through this. So I have closed this. That's what I shown as a cross mark. And you are evacuating the power through this. And you will see some equipment. It's called current transformer. What it does, it is converting. Sorry, I just made a wrong thing. It's actually voltage transformer is up and current transformer is down. This is the current transformer. This is the voltage transformer. So what it does, the current transformer, what it does, on your primary conductor, you'll be flowing around 500 ampere or 1000 amperes. And you will have a voltage which is on 400 kV, 765 kV, 220 kV. But for a protection, if you have to monitor this, how this current and voltage, whether it is crossing the limit, I cannot feed this current directly into a device to monitor, because you have electronic devices which is monitoring this. So what we do, we are stepping down the primary quantity into a secondary quantity. For example, if 1000 ampere is flowing here, it will show you send only 1 ampere here. So your device will only 1 ampere, so see only 1 ampere. So since being a small device, it can handle 1 ampere, not the 1000 ampere. And same as a voltage transformer, like 765 kV, it is on the primary side, it will have 110 volt on secondary side. So through this transformation, so it can know that if I'm crossing 1000 ampere here, or it is going to 1500 ampere, so it will say 1.5 amperes, it will see here, or the function inside this device, it will understand there is something wrong. That's what I'm going to show you in the next things. Hopefully it goes. Next slide. So this is a fault. This can be any fault, like R and Y phase has got connected because of some reason. It's called short circuit, or R phase is connected to earth, so it's an earth fault. So this is not a condition which is really, it's an abnormal condition. So you have to take an action, because if the current flows beyond a limit, definitely and it is going to produce some heat, it is going to damage your conductor, which all connected part it is going to. So, and it also your current temperature will rise rapidly if the current is flowing for more time. So the most important thing in the protection is that it doesn't care. It says that if something is, something is wrong at a place happening here, so it will find out feed the of the current which it is supposed to flow through that conductors. So what it does, it sends two signals basically. So one signal, maybe it's basically to isolate. It says that open your switch, automatically open your switch. And also second signal, it tells this device that you don't worry about it, I am taking care of this specific, because this fault is near to me, so you don't operate, because if it operates, it is going to shut down the complete bus and all other feeder will be lost. So that is not a desired condition. So what it happens, sorry, I think, yeah, goes a little faster. That means, okay, so what it does basically, I lost one slide in between, looks like. Here, it is open your circuit breaker and so that your voltage is not applied to the fault, and this current will become zero, because you don't have fault anymore. So that's the way the isolation happens. So this protection IED means intelligent electronic device. That's a term we normally use it in the substation automation world. So it operates the circuit breaker, and it opens the circuit breaker and isolate this thing, and the current becomes zero. That's the way the protection function acts. Apologies, I missed one slide which shows that this circuit breaker is open and this become black. So black means that it is not energized, to easy understanding. So that is about protection function. This is one of the protection function, but there are many other protection functions substation automation. I just shown you one earth fault or overcurrent or earth fault function here. Next is the functionality which I mentioned in the first slide is a control. If you remember, protection, control, and monitoring. So control means there are many big switches. What you see, this is like there maybe it's a very heavy mechanism. When you have to close and open your switch. So what we normally do, you don't go to that place, locally to the place, and you don't operate a lever to close or open the switch. What we do basically, there will be a SCADA, supervisory control and data acquisition system. It will have an HMI, human machine interface, where you have screens. You will select some switch which has to be operated, and they'll say close it. So there will be a information going from, I'll show in the next slide, go from here to the switch to operate it. So if I go to the next slide, you can see it here. It is sending a information here. If you see, okay, I was a little faster here. So it is from the HMI, you are sending a command to this device called protection ID, or you can say control ID also here. And this one is giving an information to the switch that there's a coil in the switch which you have to operate, and it will open it. So in the next this one, what you see is that you're operating the switch, it's opened, and you're cutting off the power transmitted through this specific line or feeder. This is control functionality. So we have okay, I missed the monitoring functionality. Okay, so we have totally on a summary substation automation point of view, we have three functionality which I was explaining. One is protection, another is a control, and last is a monitoring, where the monitoring means you would like to see that what is the current flowing through this line, what is the position of the circuit, all will be shown in the screen. So you can see that what is the current status of the your substation or your bay. You can see that. So this is a summary of the substation automation function. And if you have any question at this point, you can ask. I'll give a 10-second break. HMI is human machine interface. Human machine interface. Yeah, it's a good way to ask question directly writing on the screen. Good idea. Okay. Now I'm just moving to some more terminologies in substation automation. So I'm just representing the same bay here. I have removed the transformer. I didn't want to occupy some space here. You have bay 1 and bay 2. Hope you remember what is bay 1. It's a collection of equipment which brings power into the substation and or evacuate power from the substation. So I'm just showing two bays here. And you have this voltage transformer, current transformer, and some lines. And you have this protection ID or control ID. You can say this is this looking at this bay. And you have a HMI, which is looking at all the bays in a substation. So we have different levels. We say when you for a substation automation functionality point of view, we say first level is a process level. Processes are things really happening, the real stuff happening, like current is flowing, the voltage, current is flowing, and the circuit breaker is opening and closing. So the devices which is close to the real activities, like in your substation, we say at the process level. So all the devices very close to the process is called, we say, as a process level. For example, this current transfer, these all are equipments on the process level. Second is or some devices which is looking at the bay and do some functionality. For example, now you have one ID. Sometimes in some utility may use 2 IDs or 3 IDs, depends on the functionalities. So devices on the bay level are, the devices which is looking into the specific way, collection of devices, those equipments will say the bay level devices. And the last is the station level. That is the like mainly some SCADA thing, which looks into the complete substation, and that's called station level equipments. So these are the three main 3 levels in the substation automation. I'm introducing some terms here. Don't worry much about as of now. I'll be explaining them a little bit later. These are some terms. We say goose when you have to transmit some information between these 2 devices. If you might have seen that when I explained, when a device saw a fault, it says the other device that please do not operate because I am taking care of this fault. So this kind of information we send it through goose. It will come later, this one. And you have something which is called control, right? I mentioned the control from HMI to this device, and you are operating a circuit breaker. That's called control. Report means this device say that what is the condition of current, what is the current which is flowing. That information you're sending is called report. And together we call it as MMS. Don't worry about is manufacturer message specification. And there is one more term called IEC 6158-1 station bus. I'm going to bring up all these terms, detail in the coming chapter. Just know that where it lies, these kind of terms, where this functionality exists in the substation. One more, next slide. If I go, I'm introducing a new equipment in the substation automation function, which you can see it here. These all part is same. Your bay level and station level is same. But I introduced a device here. If you've seen that, it's called MU is called merging unit. When I send out the slide, I will put that what is abbreviation means. It's called merging unit. What is the importance of merging unit? I will just explain you here. You might have seen this air insulated station, right? It's such a big station, and your current transformer field. And if you have to bring your current and voltage for the bay level devices, this bay level devices normally you keep it in a confined place. It will be air conditioned place. It will be in the control room, or you have protection rooms. So you have to bring all these wires from this current transformer, voltage transformer, to this device, this bay level device. You might have seen in the previous picture. You're bringing all the wires into this this bay level device. So it will, if you really look at, it will run in thousands of kilometers sometimes if it is a big substation. This all the wires. So you have a infrastructure requirement to bring these wires, and also it's a expenditure, capital expenditure, and also there are some safety factors as well, which I think I may not touch upon this session. So what we have introduced in the 6180 standard point of view, substation automation function point of view, set a device called a merging unit. What it does, it takes this real analog value and convert into digital value. And then once it is digital, you can send it to a single line, right? In either Ethernet line. So multiple merging unit, you can, send it through a digital line to the bay level. So thousands of kilometers of wires we are reducing through this. So this device sits very close to this, process level, very close to the current transfer. What it happens now, current and voltage is, instead of coming separately to this bay level device, it is coming through a, optical fiber. Mostly you are saving a lot of money as well as a lot of capital expenditure there. I just touched upon the subject to understand that what are the different level and what are the different devices which is we see it in this different level in the substation automation function. If you have any question at this point of time, you can ask. Okay. I assume that you don't have any further question here. So MU is merging unit. Yeah, ADC. It is an ADC. I think it's a good way to ask the question, right? Very intelligent. Good. Thank you for asking that. So, the same picture which I have shown here, I just put it. This is some Google I searched and I put it here. It's not created by me. So you can see that you have a process level, some devices like merging unit and everything. Then you have bay level, which devices which you're looking at each and every way. Then you have the SCADA or HMIs here, and you have this like Ethernet buses here, which I mentioned as a station bus before. You might have seen in the previous picture. It's called station bus, and also it sends some data outside. But the first standard of IEC 61850 only is within the substation, not outside the substation. So my explanation of the substation automation will be within this purview of substation. I will not go outside the substation. Okay. So yes, please.
Yeah, I'm Guruswamy, professor and colleague of Amrita ma'am. There are 2 questions in the chat box.
Yeah.
Can I read it?
Yeah, please do so.
Yeah, if bay level means DC system is one of the question.
There's an interference. Can you mute others maybe?
Yes.
Yes.
Yeah, now you can ask the question, please.
Oh, still there is an answer.
MMS is manufacturing messaging specification. This is basically a very old standard. So it's not really invented by IEC 61850. So there are some protocol which is used in the for the report and control functionality.
And there is a question like it's 4 to 20 milliamperes transmission or else.
Where in bay level?
Oh, yeah. I think they didn't mention it anywhere.
So I mean, here it is basically, as I've explained, if the 1000 ampere is flowing through this, it will convert, and mainly its current transformer will have a 1000/1 ratio or 1000/5 ratio. If 1000 is flowing, it is 1 ampere analog value is being sent here. It's a sine waveform, analog sine waveform, not a DC one. Same here is a voltage. Once you cross here, for example, this here, it's a digital 1 zeros. In a specific format. It's called the IEC 61859-2 process bus. There's a standard how your packet should look like. So this has become digitalized here. Analog ends here at this part, and you have a digital here, and you have a digital here as well. This is a IEC 61859-2 process bus. This is for transmitting current and voltage in a specific format, in a digitalized format.
Another question, where is distributed control system in the diagram?
What is that? Distributed control system.
Control system.
If you look at it, it's basically distributed control, because if I look at this device is looking at one bay, right? So it is your control of one way is through one device, and you have multiple devices. So your control is localized to a specific way. And if I think I put every functionality, I just make it blank, and I bring all the functionality here. Like all the bays are monitored, and from this level, if you see this on station level, then you can say you have a centralized control and monitoring and protection. Here you can see it's basically distributed. And distributed, mostly we will be using it in your power plant control. Substation automation, we use that term, but not very frequently.
The other question is how? Yes. Yeah. The other question is how MU is different from PLC.
PLC is basically, if you look at programmable logical control, right? So programmable logical control, basically what it does, you have an automation function. Automation function means you have some inputs, and say that according to this input, I am supposed to give an output. So you have a PLC, working in that way. You have some specific input, and as per the automation function, you create an output. Merging unit is basically, it doesn't do this kind of intelligent operation. What it does, it only convert your analog value of current and voltage into digital samples and send it across. There is no further intelligence being added to the sample. It's only just transmitted in the sample as is, but from analog format to the digital format.
The other question is, which type of communication protocol is used in Goose?
This is going to come. This is just an introduction. The coming slides are there for you to understand how the Goose works.
Okay.
Okay.
Yeah, and Mr. Anup, can we take the questions at the end, because there are many questions coming up? We have question and answer sessions.
Definitely. I think, look at, let's do a timekeeping as well. I am on 17th slide and I have around 40 slides to complete. I may become a little slower when I go to the real, IEC 61, when I'm starting to explain this, 61850 standard. So these all are very generic terms which I'm explaining on the substation automation function point of view. I have not reached to really the standard yet.
Okay.
Okay, so I'll proceed now.
Yes.
Okay, great. So hope you understood what I explained here. I'll just summarize. So you have different base and you have different levels in a substation automation function. There are equipments in different levels, as you have merging unit current transformer. Then you have one bay level devices which are looking at a specific bay and do the functionality. And you have station level device like SCADA, which is looking at the complete substation itself. Let me, next slide. So this I was explaining also, so let's not put much effort here. So hope you know about IEC, definitely, right? I mean, so you might have heard IEC standard. It's an International Electrotechnical Commission in the world. It's a leading organization that prepares and publishes international standard for all electrical, electronics, and related technologies. So, and the specific standard which we are covering in today's session is also from IEC. So there are now third revision of the standard is already. So the standard name itself is called Communication Networks and Systems in Substations. Then that was up to 2007, 2002 or 1 it was introduced, and then in 2007 they understood that this standard it is not only within a substation, but it can also can be extended to the utility. So they created a new revision of the standard called 2.0, which you can see the name has changed from substation to power utility automation, communication networks and system for power utility automation. I will be touching upon edition 1 because edition 2 there are changes, but I think to understand the basics of the standard and automation, edition 1 is sufficient. This standard consists of many parts. Basically, each and every these parts may be of 200, 300 pages. So the introduction, there's a part 1, part 2. There are some glossaries explaining what all are the different terms there. Then you have many part like 7- application guide. For example, it explains from the substation automation point. Gajendran, can you please mute your line? Yeah. So application guide which explain about substation automation functionality. Then there are data models. So there are many things which is required in the standard, and there is one final standard called 10, which is actually a conformance test to make sure that if some manufacturers like ABB says that my device is as per the standard, someone should make sure that it is actually they have implemented as per the standard. So there are some specific part which tells how this has to be tested to make sure that somebody has implemented this standard in their devices. Let's not go into the deep, but just to give an idea, there are many parts of the standard. If you are looking at, so everyone will not be an expert in all the standard, all the books. There are some specific part which is specific to a specific functionality. For example, There are engineering, there are some, for example, I am not able to find it out. It's called 6.925. You have some engineering, some person will be only interested in the engineering part. So they will be looking at only this engineering standard. Someone will be interested in the data modeling part. So they will be looking at this 7-4, 7-3, this kind of standard. That's a way, someone will choose which, specific, the standard to read. Okay. So why we started IEC 61850? Now, if I just go back to the previous diagram, I'll just go back here. If you see my slide number 17, you see one. Mr. Chetan Varia, can you please mute your line? Mr. Chetan, please mute your line. Yes. Okay. Then we have if you say there are one device here, another device here. This is from ABB, and this you think that it is from our maybe competitor like GE or Siemens. English and another is talking Hindi, it will not be able to communicate. So that was the case before 2000. Actually, each and every manufacturer we will be implementing the communication in a way that their device can communicate to only their device. For example, ABB will be communicating to another device of ABB, not to the device of Siemens. That's why I think utility itself will not like that, because then you get locked to a vendor. I mean to say, then you have to always take ABB devices, but they may be interested in taking the mix of device in the substation, like from ABB, Siemens. So that is the main idea of this 61850 standard. I'm just going to this one. Interoperability. Interoperability means, it should be possible to implement the substation automation function by taking different devices from different manufacturers. So that is one part, interoperability. That's the main idea of bringing this standard. Free configuration. I'm not really touching upon this topic, but somebody had asked a distributed control system here. So I mean to say, I can make these functions in a way that I can have individual IEDs for a individual base. It's called distributed. And even it's possible for me to bring all this functionality into a centralized location on a station level. So the standard is designed in such a way that I can do both. I can have it in a distributed way, or I can have it in a centralized way. Third is a long-term stability, mainly on the communication technology point of view. Because you know that your electrical protection, your monitoring, control, and everything, it's going to be the same, I mean to say, after 50 years also, because you are not going to change current into something else. Voltage will be voltage, current will be current, and opening and closing switch will be the same, like you have to open the close. But what is rapidly changing is the communication technologies, which is the real one, with the protocols, what we use it. Standard has decoupled this basic functionality of a substation automation, like monitoring or opening, closing of switches. I'm just putting a very layman's term here, not a real technical term. And they decouple this with the real communication technology. How it helps? Basically, somebody is inventing a new communication technology. You can just remove the old communication technology, what is prevailing, and plug in the new one. That's the way the standard is designed. So it has three aspects. So it's it's basically you are without changing much, you are adapting to the new technology. That's what long-term stability means here. So these are the main thing. Interoperability. So different manufacturers can communicate. They speak the same language when they are exchanging the data. Free configuration. You can have centralized and distributed, and long-term stability, which I mentioned that it can take care of the new technology coming in the world. The interoperability I explained with a simple diagram here. So you have ABB SCADA, Siemens SCADA, and you have ABB device, Siemens. So you should be able to communicate. Everyone should be able to talk to each other. That's the way standard is designed here. This is interoperability. Okay, now I am little bit deep diving into the standard now. How we are achieving the interoperability. I am going to touch upon the modeling aspect, how we model the function inside each and every box inside such a way that when it sends a data to another device or it sends the data to the SCADA, they understand. So you have a standard modeling procedure. So some new terms is going to appear in the coming slides. Okay, so interoperability, how we are achieving interoperability, what is needed for interoperability. Don't worry about what I wrote here much. I'll just explain you here. There are standard part like 7-3, 7-4. I shown you there are many parts. This part tells about basically how you should model your function inside a substation automation for the substation automation functionality. So I'll be touching upon 7-3, 7-4 modeling. I will not go through this. This is actually the part 2 of which I was explaining. Then you have something called, engineering also. For example, there are two devices. I say that they comply to IEC 61850 standard. Siemens says that I have 61850. ABB says I have 61850. But make them talk to each other. You cannot. It's not a plug and play like what you have Bluetooth, right? When you have just switch on Bluetooth and connect. It's not like that. It needs some sort of an engineering to be done. So configuring the data and sending the data to another thing. So some engineering. So there's a common standardized engineering data exchange. It's also defined in the standard. So all the manufacturers should follow this standard way of engineering, how to send the data from one to another. This I will explain a little bit in the coming slide. And finally, also I say that devices like GE and ABB says, okay, I have done all the standards. They say I'm fine with that. But as an utility or power grid or MSCB or any utility, how they will get a confidence that, okay, if I buy the device from ABB and this device from GE, whether it will talk to each other in a language which they understand, because it's a lot of implementation has to be done. That's why the standard came up with the number 10. So what happens, before I create a product and before I am going to sell it, I have to make it undergo some testing in some vendor independent labs. Basically, there are labs which is not connected to any manufacturer. For example, there is one of the lab is Schema, which is in Netherlands. So we have to take this device to the lab and says that, okay, I have done this, and they have standard testing procedure, and they will give you a certificate saying that, okay, now your device is following this procedure. So then what happens, your utility customer, they can see the certificates and say that, okay, now I can buy the device. So if I buy these two devices, they will talk to each other. That's a very important thing in the standard, which making sure that we say interoperable and everything, but it's also make sure that when the manufacturer implement that, you have to go through a conformance test before you are going to the market. So I'm going to touch upon this modeling part. I'll take very basic example for you to understand. So some terms are coming here. I'll try to explain in a very basic way so that you understand. So one term is called logical node. Now all the functions in a substation, I mentioned you there are some function like current you wanted to monitor. Another function may be temperature. I would like to have a look at it. For example, substation has a transformer, circuit breaker. It's very important for you to supervise the temperature. So this is one of the functionality for that. And there is another function like if the current is crossing beyond a limit, I am supposed to isolate that part so that it doesn't damage the other system. So you have overcurrent protection. So you have maybe hundreds of these kind of different functions. Now I have listed only 3 here. File share, can you please mute your line? File share, please. Yeah. Yeah, thank you. You have overcurrent protection, temperature supervision, circuit breaker, representation. There are different functionalities there, which is common. It is prevailing. It is not something which is newly invented by the standard. It is there from maybe hundreds of years, or maybe till we have this electricity invented, and then you have a transmission and all started happening. So these are nothing new. But what the standard has done, they standardize this functionality with a name. For example, anywhere if somebody says that I have an overcurrent protection, and it say that I have a PTOC function inside my product, that means overcurrent protection. So everyone will know, who knows about substation automation, PTOC means overcurrent protection. STMP, somebody says, my device has STMP functionalities. They say I have a temperature supervision function, but some temperature supervision function. And one device says I have an XCBR in my device. That means there's a circuit breaker, representation of data inside that function. It will give you the position of circuit breaker, these sort of things. So they have standardized, and this standardized, the smallest functionality is called logical node. Now, function we have defined, but each and every function also should give some meaningful output, right? For example, overcurrent protection, if something goes wrong, it should give an output called trip. You have to trip your circuit. Trip means open. Another term we say use it as substation automation. Trip is opening of a circuit breaker. So each and every this function has also a collection of meaningful output. So that meaningful outputs are called data objects. So for example, these all are not one-to-one matching with this what you're in logical node. I just generically put, for example, you have WRN. Someone says that I have a logical node in my function, in my product, and there is a WRN in that. Then I know that there is a warning functionality being implemented. And there is an ALM there. So there is an alarm functionality is implemented into the product. TR means trip, postman position. So this is some standardization is being done. So each and every this kind of functionality will have a collection of this kind of data object. This is being specified by the standard as well. So overcurrent means you will have a trip, or some other information, what was the current it started, or some sort of information. I am giving some wrong example here, but this sort of information, each and every this kind of PTOC, STMP, XCBR is supposed to give. I am going to take for the next example STMP, and I am going to explain how does it look, that functionality, and how I'm going to model it. Now I'm going to introduce one more term. Now warning is just a data name. I know that warning means there is a warning information there. But warning is sufficient for us for at least to understand what this warning contains, because warning is a binary data, right? It says that it is either in the warning level 1 or 0. There is no warning. So that is one interesting data I would like to see in the warning data object. And another thing I am interested to know from the substation automation point of view is that when this warning, data change, that from 0 to 1, a timestamp. For example, this is very important for a substation automation function. When you are analyzing, we will look at, okay, when this warning has happened. So this timestamp also important for. So warning only gives an information, but it has some attributes under that called the value. You should have a value, whether 1 or 0, and it has a value called time. For a minute, it's all okay. Great. Congratulations, sir. Okay, thank you. And did you miss anything here? I think if I have to explain again. Okay, great. Thanks. So I'm coming back again here. Okay, so you have a standardized way of representing the functionality. Then you have a function really, which the data object. Hello, Bhavya, can you please mute your line? So then you have a data object and the common data class. Okay, I'm now. Hello, Bhavya, can you please mute your line? Hello, Bhavya. Please mute your line, and someone else also speaking. Okay, good. So now I'm just showing you what is a logical node. I'm taking only one example, STMP. is a temperature supervision function. So as I mentioned, if someone manufacturer says that there's an STMP inside, there's a temperature super function, I know, inside that product. So I mentioned here, this is the STMP class. This is a table which you will see in the standard. There's an STMP, then you have a data object I mentioned. So this STMP temperature supervision function has a data object called alarm, trip, temperature. These are the important information which this function has to send to others for other device or other SCADA for them to monitor it. So then you have a description of each and every the data object here. If you remember, I already explained the data objects in the previous slide. So you have these sort of many tables in the standard. That's in 7-4. STMP, you will have one PTOC, which I explained before, XCBR. There are many tables for each and every output you can expect from each and every logical node. Now what I am going to do, how we design, because for example, I have a STMP functionality I wanted to implement in substation automation in my device, in my ABB device. But I'm not interested to implement all this output in my device. I'm only interested to say that, because for my functionality point of view, I'm interested only alarm and trip I want to send from this. I don't want to send anything. So as a manufacturer, I can take this class STMP and I can create a meaningful function out of it. So how I made a meaningful function. So I'm taking this STMP class, and instead of taking all this, things like temperature, operation count, reset, EEL, ename, everything, I'm interested only alarm and trip. So I design my function in a way that I only send the output for alarm and trip. And at least for me to know that what is that functionality all about, I will give a prefix to that, because I am not directly using the STMP, but I am creating a type of that STMP, a logical node for me to understand. For example, we give a meaningful prefix here. CNC means for my product, maybe it's a conductor temperature. Conductor means, if you in the power plant, you might have seen there are bus bar carrying very heavy current. So I would like to monitor the temperature of that bus bar. So I'm designing a temperature supervision function to monitor the conductor. So I say it can be anything. This is a manufacturer which does a CNC STMP one, and I am choosing only alarm and trip for my functionality. I'm just leaving other part when I'm designing my function. Further going now I also mentioned that about alarm means it only a name. I know that there is an alarm, but also I am interested to know that what is the internals of that alarm. Like there are attributes I mentioned, the value, whether alarm state high or low, or when that alarm happened as a timestamp. So we use a generic common data class SPS for representing a binary type of information. You have many type of, if you look at here, there are many type of common data class. If you look at alarm and trip, I use the same SPS because it is a binary information. It is, so I can reuse the attributes for representing alarm and trip. But when on the substation automation functionality point of view, alarm and trip has different meaning, but the attributes may be the same. For example, alarm can have a same single point status, and trip also can reuse a same single point status. And if you look at temperature, this is a TMP. It will have a different, CDC class. It's called measurement voltage. I don't remember exactly the full form there. And you have a IEC integer control. So there are different CDC classes, common data classes. But I'm going to explain for you to understand. I only take the SPS, which is easy to explain because it has only it's a binary information. So I'll just switch to the slide next, and you will understand what the single point status is all about. So I have enlarged that single point status. So as I mentioned, I have a value. you have a timestamp when the value has changed. So the alarm can, to represent the alarm, I am using further attributes called stval, q and t, which is the part of this single point status. If you have any question here, you can definitely raise, I can take it up if you, because this is a little bit more deeper into the standard. So don't worry about this, what I'm showing here. So I'm just summarizing what I've explained here. So you have I created from the STMP class, I created a meaningful function for conductor temperature by conductor temperature supervision by taking only alarm and I have an stval, q and t for that specific alarm. So what you have in a Windows folder, you will see like CNC stmp1/alarm/stval. This is the way you represent each and every information from this, this function. So I'm only showing the alarm here and not the trip. So if on the modeling point of view, if I have to refer to a value of alarm in my device, I should follow this path. For example, CNC STMP1 alarm and stval. And I will also have quality and time. So one value has a multiple attributes, because these multiple attributes are required. Multiple attributes are required for substation automation function point of view, because I would like to see what is the status of alarm, what is when this alarm has changed its status. Okay. Now I am going to introduce one more term called logical device. As I explained you, I shown only one logical node, like STMP, CNC STMP. That's the temperature supervision function in my device. Then, but in a device, you will have multiple functions. That's because of the invention of your digitalized, intelligent electronic device, multiple functionality I can put in a single box. So in my box, there will maybe temperature supervision function, there will be current monitoring function, voltage monitoring function, and I can put them together in a box. But we also do one more layer inside. We will same kind of function, we club them together and put in a container. That is called logical device. Why we do that? For example, when I have to test and see that the similar kind of functionality, I want to switch it off for some testing point of view. Then I'll go to this container level logical device. I can switch off the functionality so that all other function under that will get switched off. All the logical node under that will get switched off. So otherwise, what you have to do, you have to go to individual functions and you have to switch off the function. So logical devices we have created, it's a kind of a meaningful collection of logical nodes for performing a common action. So how it will look like? This is the physical box, what you see in a substation. But for a communication point of view, you will see your device as this way. I will don't worry about it. I will explain each and every part. So first, if you have to know from the communication point of view, you should know the address of your device. Basically, if you look at the pin code of your place, right? For example, my pin code is 560067 Bangalore. So that's, that is the first level of information for a communication point of view. I'm putting there is a name for the ID. Then you have a multiple logical device here. As I mentioned, that under this you will have many logical nodes, different function. One of them is STMP, which I have explained before. So when I go here, next slide, this is a collection of logical. I'm going to bring this this picture in the next slide so that you will understand better. So now you can at least a little bit relate. So this is that, the name, the pin code of that specific device, and you have logical device. Now you can see that this is what we have designed before. So in one of the logical device, the function which we designed in the previous slides is here. So it's a conductor temperature, and you have similar kind of many functionalities are here. So as I mentioned, a logical device has many logical nodes inside this. Logical nodes means it's a specific function inside your substation automation. So overall, when you look at it, how do you reach to the data? You are reaching from here. I will show in the next slide here. And finally, you are getting the alarm value by browsing through this all the data. So if you look at here, this is the way it goes. So the complete representation of the data from the modeling point of view in a device, if I have to get an alarm status, you have to go through this. Like you have a pin code of that device, then you have a logical device where this function is residing, and what is this your uh, specific logical node, and you have a alarm as a functionality, then you have a finally the value which is carrying. So this is the way you represent the data in the in the in the 61850. So this is what I meant by the common data modeling. So every manufacturer follow this standard. For example, it is if you have to browse or get a data from a device of Siemens or from GE, we can the same kind of modeling a little bit, maybe here and there minor changes will be there, but they will follow the same standard way of doing that. So you can see that now at least the language spoken between this IED will two devices will be the same with this kind of a common data model. And during the conformance test, as I mentioned, third party confirm, they will make sure that you are abiding with this data models. You are designing your data model. Otherwise, what will happen if I say that I have modeled in this way and another device from another customer is trying to get the data, it will not be able to read it because you have violated some standard there. So this is the first level you required for two devices to talk the same language. So this is called data modeling. So we test upon a logical node, which is the the functionality in a substation automation, and then we test upon data objects like alarm warning, and we test about CDC class, which is a collection of attribute called STVAL, T, quality, and everything. So this ends the data modeling section. If I think we also a little bit running out of time. We have 21 minutes more. So I will go to the next slide. I have there is one thing which I did not touch upon this. You might have seen some Q here. It's called quality. So when I'm sending one data from one device to another device, you never know that if somebody is sending the real data from the process or they are testing something and sending the data, like they're simulating the data and sending. This is also can happen, right? When during the testing, you can simulate some data during the testing and send the data. So during the simulation, it will this quality, it's a 16-bit data, or now it's only 12-bit here. It will set bit 11 saying that now the data being sent alarm, which is being sent, STVAL may be 1, it is sent on a test, in a simulation mode. So this quality information is also very important when I'm sending the data, so that the client or the one which is subscribing the data understand that this is not the real data, but it is something it's simulated. Also, it can be that there are some issue while computing the data, then you can give it's a bad data or it's an invalid data. This kind of information you can send us. So the quality also on the attribute point of view plays a big part when I'm sending the data. Okay. So I'm just again giving a cross-section view of how does the device look like. I took different logical nodes here. So this is a physical device which I shown before when I was showing the IED from ABB. Then I'm cutting across. Then you will see a logical device inside this. The first level logical device, a collection of logical nodes. Then you will see a logical nodes inside, which is the functionality, the smallest functionality, substation automation. XCBR it represents the circuit breaker. So if I go into circuit breaker, I'll get the position of the circuit breaker, and you will get the data attribute of the circuit breaker like STVAL and quality. Then you have a MMXU is basically for the current monitoring. If you have to monitor a current which is flowing through a primary device, we use this functionality. So A is ampere. It's a data object is ampere, and you can see further data attributes phase A current or phase B current. So just to get a summary of what we have explained here. And now we have modeled it. That is fine. But you also have services. So modeling is not sufficient, but you should have some mechanism to common mechanism to transfer the data from one to another device so that they understand what they are speaking to each other. So I'm bringing the previous picture again here, which you might have seen, process plus goose, and I'm going to talk about specifically the report part. For example, how a data from a bay level device, the IED, is sent it to the SCADA, so that I can see the temperature is correct or not, or your current is flowing correct or not. This is something which I'm going to explain you. So before that, I'll just read through the common services which have in a 61850. So we have mainly 4 services I listed out, but there are other services as well. There is control service, report service, which I just talked about, then GUI service, this I will explain later, and file transfer service. Control service, mainly I mentioned the opening and closing of switch. How do you do that? It's a commands from your SCADA to the device, the circuit breaker. Report service, as I mentioned, if you wanted to show an alarm status in the SCADA or the temperature or the current, that is, we use report service from the bay level IED to the SCADA. GUI service is basically, it's a very fast protocol which send the information from one ID to another ID. I've shown you initially a substation automation function where when the fault occurs, one ID is telling other ID not to operate. That should be a very fast operation. So it's a send a blocking information to another ID. It's actually blocking the ID. So this is used by GUI service. Then you have file transfer protocol. That let's not go into those details here. So I am touching upon the report service. Report service, if I just bring back your picture here, this is the report service, like from sending a data from your IED, which is looking at your bay, and sending to the SCADA. So how do we do that report? It's a two-party association. So you have a client and server. Server is your protection device ID, and your client is a micro SCADA or SCADA. So you are sending some device from server to the client. If you remember this picture which I have shown here, so how do we make sure that we send the data from the server to the client, ID to SCADA? So there is some terms which is used specifically in 61850 language. So what we do, you might have seen this diagram, like you have this is a pin code which I was mentioning, and you have many logical device, the collection of logical nodes, and I am interested as a substation automation engineer. I'm interested to send only this conductor temperature which we have designed before, alarm status to the SCADA. So what is the first thing what I will do? I will collect the data from here. There's an engineering procedure there. So I collect the data through an engineering. It's called data sets. So this is the data set which I am sending, but just adding a collection, it is not going to send data, because you have to add some communication attributes to that. So that's why a new term comes. It's called leave it. It's called report control block. So I'm adding a top layer on this data collection of data set. It's called report control block. So this is the one which enables sending the data from the server to the client. So as I mentioned, you have a collection and as attribute for communication. So I'll go to the next slide to understand what all are this attribute for data exchange. So you have a report control block here. So now I decide, I don't want to send the data continuously, right? For example, if you're trying to continuous the data, you have a bandwidth issue in your communication medium. These are Ethernet cables. So I'm interested only to send the data when there is a change, right? Because there is an alarm 0 to 1 comes, then only I'll change. Otherwise, there is no need of changing. So there are different kind of trigger mechanism we design. For example, I say, I want to change the data only during a data change. So for example, alarm STVAL become 1 to 0, it will send the data. Now quality change. I say I would like to send the data when there's a quality change. I explained you quality before in the slide. So alarm.q, when it changed, then only I send the data. Then there are other options called data update, integrity. Integrity means I can put every 100 millisecond I send the data, or every 1 second. It's a cyclic thing which is, and it doesn't look at if there is some change or not. So there are different way to send the data to this one. So this is one of the engineering we do before we send the data. So this has to be set. So whenever there is a in my device there is alarm has changed, it immediately push the data. If I set it's a data change or quality change. Also, there are two aspects of there are two kind of reporting we do it. One is called buffered report, unbuffered report. I will explain you what is the significance of it in the next slide. Okay, I'm just running a little bit out of time, but I will try to manage it. Sorry. Okay, I have two kind of reporting mechanism. One is a buffered report control block. Now, what I said, there is a change in the data, and I am sending the data to the SCADA. But think of a situation where there's a communication breakage happened because of unfortunate reason. So your data will not be sent to that, sent to your client, and your data is very important. Data is being lost. When you have a major, I mean to say, issue in your power station or utility, you have a cascade trip. Everything trips, and you have a blackout. We would like to look at each and every event happened in a chronological order, like what happened first, what happened second, so that to understand what is the real cause of your your blackout. So this buffered report control block play an important part there, because I will not immediately a small time here, a buffer time. So one event comes into my buffer, it will wait for this time to elapse before you are sending the data to the client, and also it makes sure that the client reaches the data. So what happens, the important data which is required for analysis will not be lost, but if you go to the unbuffered report control block, there is a chance that you will lose the data. So you will not put very important data which is required for analysis in the unbuffered report control block. So that is about the reporting service. Hope you understood. Now, second part, somebody asked a question of Goose. So Goose is also, it's almost same like a report control block, but it is a very fast acting. You have to send the data immediately. For example, report you don't have to send, because it is actually reaction time, because you are sending the data and to show it in a screen, and the reaction time of human is actually it is in seconds. So you don't have to send the data in milliseconds to the data. It's a slow protocol. I mean, the slow transmission of the data. But the Goose is it is in milliseconds you are supposed to transfer the data. The reason is that if you have a fault here, and if this device doesn't tell the device immediately that in 10 milliseconds or something that I am taking care of this, you block it, it could be that it will act and trip all your substation possibly. So the Goose is a very fast acting information exchange. Goose full form is generic object oriented substation event. Before I mentioned, it is in the report service a two-party association. There is a client and server, where server is sending the data to the client, and server and client know each other that I am sending the data to a specific client. But in Goose, it doesn't know whom it is sending the data. It is just pushing the data in the network. It's called multicast, and the device which is required to take it has to pick from the network and then take into its application, do act accordingly. So how do we do engineering? Same as a report mechanism, it also has a data set. But here you can see a change that I am not putting a time here. It's only ST-val and Q. I will not put a time, because time is not important when it comes to real time. You are supposed to immediately send the data. Time is important when you have to stamp a time for an analysis. You have an event sequence of events there, and I have to analysis. Here is the interesting thing is that the value and the quality. Quality is very important, because if you are putting the data in a test mode, and if somebody's acting, the device which is subscribing to the data acting, it may operate in a wrong way. So quality you have to set properly when you are before sending the data. that will be taken care by the logic inside the function. So the data set is same here, and then it also has a goose control block, which has attribute for the data exchange. So what all the data attribute, don't worry about all this app ID, VLAN and VLAN priority. One important thing is a minimum time and a maximum time. Since I do not know, since it's a multicast, Goose does this. The ID which is sending the data, the device which is sending the data doesn't know that the other one has really received the data. So we do some kind of a mechanism to make sure that data is not lost. So how do we do that? Don't get complicated with this, confused with the diagram. So if there is an event change, this is a time scale when you have this. So there is an event change here. So what it happens, immediately it pushes the data into the network with the minimum time. If I set a minimum time, because it has to be immediately sent to the next device and it has to take the action. Then what it does, since it doesn't know that this device has really received the data, if there is no the same event value, for example, alarm STVAL has become 1, the alarm has become 1, it will send again. If it is 4 millisecond, which I am set as a minimum, it will send again after 8 millisecond, then 16 millisecond, then 32, then so it goes 64. So at in an increase in the order of time till it reaches the maximum time. Its maximum time is 1 second, so it will retransmit the same data once, and so make sure that other ID lost in collecting the data, it is at least get the data in the next transmission. And then again there is some change happen here, then immediately it will start in 4 milliseconds. That's a minimum time. So this is something called a retransmission mechanism in Goose. It's mainly done to make sure that the change in the values reaches to the one which need that value. If it is missed in the first pickup, when you're trying to get the value, you can at least get from the second or third retransmission. So that's about Goose. And some performance, I'm very close to the end of this one. I have 3 or 4 slides. I can stay a little bit 10 minutes more for a question answer session if you have time. There is very important thing, since it is a communication based technology, we also have to say that because your substation automation function, most of them are real-time functions, because the current is flowing in real time, and if you don't take an action in real time, it is going to have a catastrophe in the substation. So there are some performance requirement which is being defined in the standard. This is one device, I have shown a physical device, and this is another device, and you have like STMB, temperature monitoring function, or you have some overcurrent PTOC function here. Now when you create an intelligent electronic device, you have some stack, communication stack also you have it, which when the data is sent, it goes through communication stack and comes to the network, like your Ethernet switches, cables and everything, and reaches to the another device communication stack, and it comes to the function. So there is a delay in every place. So for example, from the function, communication stack takes some time, is TA, and your physical network layer, it will take some function, and again this communication. So actually meaningful information, actually the real function is done by this F1 and F2, but these all things are because of you have your network and all other delay which is caused by different entities between to this function. So but this we have to live with it, but there is also some specification given by the standard. So it's called transfer time. Data from one function to another function, it goes through stack TA, TB, and TC. So TA plus TB plus TC is the transfer time. So the transfer times are defined in the standard for specific functionality. So these are some table which is mentioned in the standard. For example, we go from bottom to up. Trips and blockings, like Goose, which I was mentioning, you cannot wait for in seconds. It has to immediately go. Otherwise, your transformer may actually blast if you don't take an action immediately, or your circuit breaker may get ruptured. So the data exchange which is required from one device to another device during the trip condition or blocking condition has to be so fast. So we say transfer time for these kind of functionalities in 3 milliseconds. And there are some release status change, fast automatic interaction, slow automatic operator commands, events and alarms. So you can see events and alarms. I was mentioning the report. Um, when I'm sending a data to the SCADA HMI, it's a human reaction time. So it can be in seconds. So that's why 1000 milliseconds you are putting. So some functionality can still wait. So I think that is actually the end of the slide for me. So I'll just summarize what I've just explained till now. So we touched upon substation automation function different, protection, control, and monitoring. And if you remember it, there are overcurrent protection, fault protection. Control means you're closing and opening the switches. They were called circuit breaker. Monitoring, you're monitoring your current, voltage, and your temperature. Then I introduced you to different levels in substation automation: process level, bay level, and then in the station level. Process level means the one which is actually all the current and voltage. Real action happens on a high current, high voltage. Then you have a bay level where are devices which is looking at the process level and monitor and control. Then your station level which looks at the complete substation. Then I introduced also one entity called merging unit, which is something which saves the kilometers of cables by digitizing current and voltage into a digital samples. Then I was bringing this standard called IEC 61850. Why it came into picture? Because so that the utility can mix and match different manufacturer devices in their substation, ABB, GE, Siemens, everything. So main aspect was that it should talk the same language. They should do so. Interoperability is the one which I was mentioning it. So to achieve interoperability, we defined a language using logical node, data object, and a common data class. And I have shown you the modeling using STMP, like temperature supervision function, and I have shown you the address, how the address is being done there. So we mentioned that the language we set it, now we know how the data has to be transferred. So then I introduced a service called report, which is basically from sending the data from your IED to your SCADA. You are sending the data. It's a report functionality. I mentioned about data set, which is a collection of data, and there we added a communication attribute on top of this called report control block. And I also mentioned that there are different mechanisms to push this data, because always pushing the data will flood your Ethernet. So we have a mechanism called data change, quality change, and some other things which only during that time you are sending the data. Then I also touched upon buffered and unbuffered. Buffered is important because you should not lose the data. It is important for sequence of events. When you have a electrical point of view, you have a zero sequence voltage, negative sequence voltage. This we will monitor it. We will look at, then we have you will look at the pressure. Maybe most probably you have pressure relief valve inside there. I think you can have a look at that. I'm not really sure is there a modeling for that one, but definitely temperature you will look in. So there are many things you can monitor it. There are a list of parameters, but these are some of the main parameters. Yes.
There is another question from DAS 16. How will substation automation discriminate over current and cold pickup in rush current?
Cold pickup in rush current. You mean to say there are functionality basically this comes in the transformer, because transformer, when we are charging, there will be an inrush current. I assume I don't exactly remember inrush current. I think the second harmonic component will maybe, or fifth, I don't know, second harmonic component in the current will be more. So I assume that we do a ratio between the second harmonic to the, I think, the primary current, then we will see that if is it crossing some limit. So if that crossing some limit, I think it blocks the protection. So it makes sure that your function doesn't see it as a fault condition, because during a charging of power transformer, I think from this no load current, it might take around 25 times, or depends on the waveform where you are switching that specific transformer. It will take a very heavy current. So looking at the harmonics, it will decide whether it is a fault condition or it's an inrush condition.
The other question from
Hope
Das
my
again.
answer was clear to you. That's what I guess. Yeah.
Yes. The other question is from Das again. What is the general baud rate of IED?
General baud rate of IED, because it's we say mainly baud rate. It's very important in the merging unit. We'll say sample rate there. For example, if I have a current, then the minimum sampling rate, what we say is the per cycle. That's what important for the protection. So it will be around let me say 4 kilohertz. That's what we normally do for a sampling of the current, because you should have a you should reach to this sampling is required so that you can at least use that because we are using the samples for your protection function and I think monitoring function. So having more sample rate is always proper functioning. And the standard, at least from 61850 standard point of view, what is mentioned is 80 samples per cycle, which will come to, for a 50 hertz system, it's a 4 kilohertz.
Yeah. So this is the question from Nirav Mehta. What is the time critical services in communication services?
I have already mentioned that there are real time. The Goose is the one which is a time critical application here. Look at my first slide where I was explaining you the fault, where one device is saying a fault, and it is telling the other device to say that please don't operate, and I am sending a data to one device in a real time. So real time means you cannot really, real time is not possible because you have intrinsic everything. So at least in, I think, 3 millisecond or 10 millisecond, it should reach to the device. So we use Goose for this transmission. So Goose is mainly used for all the time critical information.
Okay. And this is the question from Vinay Kumar. What are the research areas in substation automation?
I see mainly research area in substation automation because my colleagues in ABB, the research mainly happens in the protection function, your application function. For example, distance protection. If you know that if you have a line, transmission line, if there is a fault in the line, then you are supposed to identify the fault and isolate that line. So there are many these kind of functions in a substation. So mainly on the application area, we have researchers which have seen it.
Yes. The other question is from Asha. When one device transfers information to another by Goose, if it fails for the first time, that other device may operate?
Other device, it depends on how your application function you have created a data. For example, as I explained, again, I'm quoting the same example where one device tell the other device that, I am not able to, I'm sending the data, and other device telling that this blocking information, it is not reaching to it. One thing is that we also have an intrinsic Goose super other device point of view. So the device, what will, it will continuously look at the packets in the network, and it knows that this Goose has come in the 4 millisecond, and I am expecting the same packet in 8 millisecond, because there's a retransmission which I explained, and maybe then 16 millisecond, and the stack seeing that there is a missing of the data. right? Then it can say that there is a communication failure somewhere. I am not getting the data which I am supposed to get it. So your application can take a decision saying that now there is a supervision of goose is gone wrong. I am not getting the packet, which action I should take. It can like block the functionality itself so that it doesn't trip your some circuit breaker since it is not getting the blocking information. So one of the way you achieve this. So if you're missing the data, you can have a supervision and take an application function take care of that in its logic. Yes, am I still audible?
Yeah, this is the question from Dr. EVC Shekhar Rao. Mention the place in India where ABB automation was implemented.
Oh, I think there are a lot in India. I think last 40 years or so. So I think there are a lot many places. I don't know whether how to look at it. There are in power grids. Power grid we have done it. Maybe in Gujarat many place. In if you come to Bangalore, I think there are also so. And we were the first one did the complete digital substation in Kerala. There is so the according to the IEC 61850 standards, the complete substation automation was done in for the first time. There are many places. It's very difficult to count it actually. Yes.
Yes. Similar kind of question from JB Pujara. In India, where substation automation implementation done?
In all the substation basically. So all the substation you should have the automation functionality. Yeah, now I'm telling 61850, but before the 61850 came into picture, the substation automation was there. It might be in hardwiring between some data has to be changed to another row one cable, connect to one cable from another, like some two cables will connect and exchange the data. So substation automation functionality has to so.
Yes, this is a question from T. Muthukumaran. Yeah. Name of SCADA software used by can be configured in the software.
It's a micro SCADA. We have it, and I think we have two things: micro SCADA, which is on a substation level, and also we have a network control level. Also, we have a network requirement. I think there are many tags. I don't know exactly the value. I think 50,000, or it depends on the requirement of the customer. I think it's scalable. Because I'm not directly working on a SCADA, so I cannot exactly give you the answer for this, but I think it is scalable. Okay. Yeah.
Yes. So this is the last question posted currently in the chat box. What is the accuracy class for all the measuring and protections?
Basically, there are for a protection, mainly we define the accuracy on the current transformer level. For example, there are some classes. For example,
presentation. And thank you so much for spending your valuable time to share your knowledge with us, sir. And you have given a knowledge on substation automation and about the standards that industry follows, and which are very useful for academicians. And thank you all participants for your patience listening. And I thank management, principal, and HOD for arranging such a session to enlighten our knowledge on industrial exposure. And we were clear about the practical topics which are said by you, sir, and we are very thankful for that. Please fill the feedback form posted in the chat box, and thank you once again. Thank you all.
Thank you, everyone.
Thank you, sir.
Thank you, everyone. So we are closing the session here.
Yes, thank you, sir.
You want to spend some time here? Yeah, I think I would like to thank you. Can you hear me still?
Yes, sir.
Yeah, so it's a pleasure sharing the knowledge from you all because I always feel that there is a gap between what is happening in the industry and the academia. Because I got introduced to the standard is in 2004. Then you see the gap. What you have it. It is around 15 or 16 years of gap which came to the your academia, right? So I think it's. Am I still audible?
Yes,
Yeah. So I think it's important as an as a academic institution to be in touch with what's happening in the latest in the technologies, so that design your elective at least according to that. This what is happening new in the world. That will definitely help your candidates coming out at least to know that what is expected from the industry. Great. So thank you for this opportunity.
Hello,
so
sir.
have a nice day.
Hello.
Yes, anyone speaking again?
Yeah. I am Dhananjay from Pune.
Yes, please.
So it was really nice session, and it was so smooth and very nice audible.
Yeah.
Along with informative, the session was really nice audible.
Thank you for that. Thank you for that feedback. Yes. Great. So I'll then close this session here. So thank you, everyone. Have a nice day. Bye-bye.
Thank you, sir.
Bye-bye.